today's session, we are going to cover what is object storage, the need for object storage, and what is the difference between the traditional storage as well as the object storage. We are going to see what are the challenges with respect to the object storage, and we are going to see some of the market forecasts and then the major players with respect to object storage. Object storage is also known as object-based storage. Here, data is actually managed in the form of objects. So it uses flat storage-based model in order to store the objects. So there will be no hierarchies, no folders, and then no directory structure as such. So with this flat-based storage model, the data retrieval is pretty easy. So that is the reason object storage has great advantage. Coming to what object includes. Object, it actually contains data. Data is nothing but what any user would like to store. It can be anything. It can be a text file, it can be audio, it can be anything. Next is the metadata. As we all know, metadata is nothing but the data about data. So it contains all the information regarding the data. So for example, I want to store a song in the object storage. In case of the object storage, one great advantage is that we can customize the metadata. We need not have to restrict to the attributes which is provided by the storage system. We can add more information. For example, as I told you, if I want to store a song, I can add more information. I can say, okay, I need artist, I need the song title, I need the duration. So whatever relevant information you would like to store in the data, so that you can actually put it in the metadata. The information, you can add it in the metadata. So the next is the unique identifier. Unique identifier is the ID, so it is actually the address at which the object is actually stored. How this is helpful? So in this address location, your data is actually stored and it helps during the data retrieval. So unique identifier plays a major role during the data retrieval. So you need not have to know the physical location of the data. So I need not have to bother where exactly my data is located. But using this ID, I'll be able to fetch the data without any downtime. So that is a great advantage here. So need for object storage. So as we all know, the data is actually exploding every day. So we have structured data as well as unstructured data. The structured data is nothing but the data which is stored in a particular format. So using your basic algorithms, you will be able to search the data. So managing is pretty easy when it comes to structured data. So what is unstructured data? So unstructured data, for example, your video files, audios, images, all these, they form the unstructured data. So we are all using the social media every day. For example, the Facebook. So Facebook is having around 2 billion active users. So just imagine, we have so many users, and every day, a lot of data is being stored. We store a lot of photos, and then we store the videos, audio files, etc. So where exactly this gets stored, how to manage this data? So there is a need of object storage here because the data is exploding, the unstructured data is exploding, and you need to manage and handle it. So that is the reason we need object storage. This is one of the report which I've provided here. The survey is being done by IDC. So it says that by 2020, around 80% of the data which is available would be only unstructured. and remaining 20% would be the structured. So we have a lot of challenge in actually managing this huge amount of unstructured data which would be available. So that is the need why we need object storage. And the data is also going to grow in terms of zettabytes. So there are various features with respect to the object storage. One is massive scalability. If you want to increase the storage, we can always add more nodes and then we can provide a good amount of storage, and this is going to scale up. So object storage is going to provide a very good amount of scalability. And then, as I mentioned, it has custom metadata. So due to custom metadata, the content of the metadata is more. Now it's voluminous. So it has the capability to actually store large amount of metadata. So it actually tackles the challenges such as security, migration, and redundancy. One more feature with respect to object storage is data immutability. Whenever you want to modify your data, a new object version gets created. So this forms the immutability. Whenever and a new ID is also created, so it becomes easy for you to search the data. So now let us take a look at what are the advantages of object storage. One is the data mobility. So due to this object storage, as I mentioned earlier, we will not bother about where exactly our data is stored. It can be stored in different geographical locations. But whenever I need data, I'll be easily able to retrieve it. And this feature is the data mobility. So we will not bother about the underlying hardware in order to store the data. Next is the scalability of namespace. So whenever you need to increase the storage, you can always attach new nodes, and then this is going to scale up, and we are going to achieve scalability. The next feature is performance scalability. Unlimited users can actually access the data simultaneously. They can do reads and simultaneous writes as well. This is not going to impact the performance as such. So this is one of the great advantage of object storage. And then coming to the storage efficiency. So there is no necessity of doing a pre-allocation of the memory. So whenever the object needs to be stored, dynamically the memory gets allocated, and then it will just use it. So there is no requirement of pre-allocation. These are the advantages of object storage. Now, let us see what is the difference between traditional storage as well as object storage. When I say traditional storage, I'm going to cover the file-based storage and the block-based storage. So firstly, the transactional units. So in case of object storage, the unit would be in the form of object. In case of file and block, it would be files and blocks respectively. So what is the supported type of update here? So whenever you need to update any data, here a new version gets created in case of object storage. In case of files as well as block-based storage, you can do in-place updates. So there is no new file which will get actually created here. Coming to the protocols. As we all know, the protocols which is actually used in file-based is CIFS and NFS. And similarly, when it comes to the block-based, We are actually using SCSI, fiber channel, etc. There are various protocols there. In case of object storage, we are going to use REST-based API via the HTTP. So this is the protocol which is actually used. Then coming to the metadata support. Object storage, it is actually going to support the customized metadata, which is not the case with the file as well as the block-based storage. In file and block-based storage, fixed attributes are present in the storage system, and they actually use the fixed attributes. User is not given any provision to have your own metadata, customize your own metadata. Object storage is best suited for static web content, as well as the cloud storage. In case of file-based storage, we have the shared data. In case of block-based storage, it is mostly used for the transactional data, most frequently used data. So let us discuss what is a major strength in all these storage systems. When it comes to object storage, the main strength is scalability and the distributed access. Distributed access because it follows the flat storage model. Also, flexibility is also a great strength in case of object storage. When it comes to file storage, the great strength is easy to access your shared files. So that is a great strength. When it comes to block storage, it has a very good performance because you are actually storing the frequently accessed data. It provides a very good performance. These are some of the measures using which we compare the traditional storage with respect to the object storage. So there must be some limitations, right, with respect to object storage. Object storage, the feature data immutability. Here we can only write the data only once, but you can read a number of times. So that is one of the limitation here, because we cannot edit the same object. So how this is going to impact? So we cannot use it for hot storage, or we cannot use it for any scratch space. So that is the reason this is considered as one of the limitation. And also, integration, it might require modification of application and the workflow. So this is the object storage model. We have the object storage layer. We have the storage nodes as well. So this interacts with the gateway layer. So gateway layer can be the cloud layer, the cloud storage gateway, as well as it can interact with the various other gateways as well. So this whole thing, the data is actually transferred to the cloud. After this, it goes to the cloud. So how data is actually retrieved? So let us see how the data is retrieved. Any storage OS, it reads the metadata as well as it has the unique identifier as well. So using the unique identifier, it will search and then it will give the object to the storage OS. That is how the data retrieval happens in case of object storage. So how does this help? So it eliminates the need of getting into the hierarchy. You need not have to search through the folders, the directories, and then get the data. So because it is having the flat storage model, it becomes easy to fetch the data using the unique identifier. So unique identifier plays a great role here. As I've already discussed, metadata allows us to provide various policies to the data. You can provide various permissions and all that. So other policies also you can actually define in case of metadata. So this is the implementation spread. This report is again, taken by one of the, ESG research reports. It says that around 24% of organizations already they are using object storage. Extensively they are using it. 20% of the organizations, they are using it, but on a limited basis. Again, 25% of the organizations, they would like to use object storage in future. Maybe in a couple of years, they would like to use. There are 13% of companies, they are actually not using object storage, but they are more interested to move towards object storage. What we can actually infer from this report is that already there is a chunk of companies who are extensively using the object storage. Some group, they are not using it extensively on a limited basis, they are using it. So they will slowly move towards using it extensively. Next chunk, they are planning to get into object storage in future. So they will also move towards object storage. And the last chunk, they are interested in doing, so they will also move towards object storage. So what we can infer is that more and more companies are getting inclined towards object storage now. And in future also, we can expect more and more companies to use it. So this is one of the, again, the market forecast. It says that by 2020, the capacity of the storage, it is actually going to increase to around 293 exabytes. And it is going to grow at a rate of 30% CAGR. So since the data is exploding in such a way, even there is a necessity for handling this data. At the same time, the revenue is also going to increase. So the expectation is that the revenue would increase up to 19 billion USD by 2020. So this is the market forecast. So object storage is already there in the market, and we already know many companies have opted it. So for example, I have just provided few of the object storage options here. One is Amazon S3. Here, the objects, the data is stored in the form of objects, and they will get into buckets. This Amazon S3 provides a great amount of flexibility, and then the scalability. You can actually increase your storage to how much ever extent you want. And then this data is present across different geographical locations. You can always retrieve the data without any downtime. So it provides a great amount of improved provisioning. Coming to the Azure, Microsoft Azure blob storage. Here, the object is stored in the form of blobs. So the container, it can handle up to 500 TB storage on a capacity limit. So it will handle unstructured data in a very structured manner. Coming to the Google Cloud Storage, here it allows you to store the data in the Google's cloud. It also provides great amount of flexibility, strong reads and writes, consistency for all upload and the delete operations as well. these are some of the object storage players in the market. I have not listed all. We have Amazon, NetApp, Dell EMC, HPE, Red Hat. We have IBM as well as Google. So object storage in perspective. So with the great amount of data actually exploding, we should have a tab on how we are actually going to manage this data. And this is going to be a great challenge. So what we can actually infer is that object storage, it will actually meet the future data growth. So this is one of the solutions to address the data growth. So it also caters to the capacity of scaling demands, and it provides the data at affordable costs. You need not have to spend much. You need not have to spend on the hardware as such. You are going to just pay for the data which you are actually going to store. Next is ease of management. So management becomes easy while actually storing this unstructured data in the object storage. It improves the provisioning. So the time actually taken to provide the resources to the users is pretty less. You do not have any downtime. So there is an improved provisioning time here. It provides great amount of flexibility as well. You can choose any of the cloud storage providers. So it is easily compatible with any of the cloud storage providers. So in this way, it provides great amount of flexibility. With this, it is actually going to reduce the capital expenditure, which we are actually going to save. So due to the encryption mechanism, we also have enhanced security with respect to the object storage. So with all these features which are actually available, so we see that there is a great future for object storage. More and more companies, they are actually getting into the object storage, and we have a better way to handle the unstructured data which is actually present in today's market, and we see that there is a great potential. These are some of the references. Any questions? Yeah, hashing is the technology used. Actually, apart from this unique identifier, so it also uses the metadata, right? So metadata might have a different information using which the ID which is actually given to the two different files would be different.
Whether this can be used.
Sorry?
Very active OLTP database, whether we can use object storage for that?
Actually, coming to the object storage, it is more recommended for the unstructured data. So when it is unstructured data, you will not be using it that actively, right? So it is not actually recommended, but we can still make use of it. But this is actually a solution towards the unstructured data growth.
And if there is a single metadata server, so how the queuing will work, because it will add more performance bottleneck, right?
Okay, so each object, when I say, I can just. So object, the data, ID, and the metadata, they're all tagged together. Okay, so whenever we are having a particular data, it has its own metadata, it has its own ID tagged. So in that way, there will be no queuing concept.
That will it have only one object ID, or it will be divided across multiple object IDs?
See, whenever you write data, unique ID gets created. So that's it. You want to modify it, there will be an object version with a different ID. So in that way, you can actually go back and then search the particular object or the data which you are looking for.
For a particular file, where do I get all the object IDs associated with a particular file while retrieving it? So
this is actually taken care by the object storage, the cloud storage service providers. Like for example, we have Amazon AWS. Okay, so it takes care of searching a particular object in the database. So that's actually done in that way. Yeah. Okay. Okay, that's a good question. For example, coming to the Facebook or any other social media as such, we can have same videos stored by different users, right? You keep sharing or you keep storing the photos or the images. The images might be same, the names might be different, so it will not actually get into the whether the data is same or not. So whatever data you would like to store, it gets stored automatically. It will not actually check for that. Yeah.
Is there an industry standard mechanism to dynamically generate the object IDs? Because I learned that there are hard drives which support object storage, and I would want to believe that something like this exists.
Okay. We have various cloud storage providers. For example, we have Amazon, we have Microsoft, we have Google. So they have their own mechanism in order to create the object IDs, as well as the metadata and all that. So this is actually taken care at that level. So it is up to the cloud storage providers. Sorry? Yeah, when it comes to Amazon AWS, right, the hardware is actually lying in various geographical locations. And then it is up to the service providers where exactly they would like to store it. As a user, I'm not worried about where exactly it is, how it is stored, and then how an object ID is actually created. So it depends on the internal algorithms what they use to actually store the data. So maybe in one of the geographical location, the storage might be full and they would like to go to the other geographical location and then store the data. So in that way, it is actually mainly based on the storage providers.
The disadvantage what you mentioned is like write only once and read many times, right? So can you just elaborate on that, like why it is just only once we can write?
No, it is actually write only once, many times. As I've already told, it is data immutability. Whenever I want to store any data in the form of object, an object ID gets created and that's it. If you want to modify, again a new object version gets created along with the identifier. So that they call it as the limitation. Because when it comes to hot storage, if you would like to modify every now and then, that's not possible over here. So mainly it is meant for the unstructured data wherein you would not be accessing data very frequently and modifying it. You would be accessing it, but you don't want to modify it that frequently. No, it would be present. Data would be present. Yeah, no, it's something like a versioning tool. The previous versions will still be present. Okay, in case of node failure or anything. Okay, so here data is actually stored in 3 different places, the same data. So whenever a failure occurs, if any of the node wherein your object is stored, it fails, then there are different copies already available and user will be provided with the data. And user will not even come to know that there was a node failure and they were unable to fetch the data and all that. So in this way, we are not going to lose the data. At the same time, we are serving the customers as well. No, user need not have to, yeah. Yes. So the service providers, they actually, they take care of, storing the data in 3 different locations, or I don't say location, we can say in 3 different places it gets stored. So they take care of that.
Yeah, hi. In the previous slides, you mentioned that as data is being grown in these days, like exabytes or something. So if you are not deduping any data, so how come, you are handling the situation? Like you have some versioning kind of mechanism. So if same data being modified some little bit, so you have 2 copies of data. So that again increases the size of storing, right?
Yeah, right. So here, as I've told you, the frequently modified data is not actually present. So for example, your video files, how frequently you edit it? Do you edit your video files? Do you edit your audio files? No, right? So in that way, very small percentage of data is actually modified, and that is being handled.
Okay, thanks. And yeah, I want to add an addition to someone asked one question, right? So you can use RAID or something to get if any disk failures happens, right? You can use RAID mechanism or something, as you said, it happens in the block layer. Block level, not file system level. So what do you have any comment on that?
Can you please repeat your question?
If any disk corruption or anything happen because of power failure or something, how do you handle that situation? You said 3 copies you are storing, right?
Yes.
So would that again increase the data sizes? So that's what my question.
Okay. See, whenever there is a node failure, see, always in any of the storage system, right? Storing the data in a secured way is really important, and data loss should not actually happen. So that is the reason they are taking care of this particular data by storing it by having 3 copies. So in this way, though the storage is actually going to increase, but at the same time, they are actually going to provide the data. They are going to serve the data to the users. So serving data to the users is more important than addressing whether we are actually going to increase the storage. So with a higher availability, so the nodes are actually connected, and then user would be able to get the data. So we can say that serving data is more important. So that's the reason we go for they go for 3 copies of data.
Okay, thanks.
So right now I do not have that information in my PPT. Yes, yes, yes. Correct. Okay. Okay. So maybe we can check on that, and then we can. Yeah.
There will be more objects. More object on the object storage, so search will be very slower, right? So if I want to do like get particularly file, it will take more time to search that in the object storage and fetch it.
Correct. So that is the reason we have the unique identifier.
Yeah, so it has to go through all the objects, right, to check the unique identifier.
No, but it will not take much time because of the unique identifier. So in other storage, for example, your file or the block storage, right? So we do not have this unique identifier. So using this, the search is fast, and it has a flat storage model. So that also adds to the searching of the data. It makes searching of data pretty fast. Okay. So if there are no more questions, yeah.
Yeah, one more last question. You mentioned about the statistics, right? So can you describe about the performance factor of it? I mean, object storage versus the file storage and the block storage, right? Do you have any figures about the performance and latency point of view on an ideal environment?
Yeah. So performance, see, each storage is used for different purpose, right? So when it comes to the transactional data or the frequently accessed data, naturally block storage is much better. So it is having high performance. So object storage, it is mainly used to address the unstructured data storage.
I got
So,
it. I was looking for any statistics numbers.
Regarding performance we
side
do
of
not have any statistics as of now. Yeah.
Okay. You also mentioned about the object-based storage is increasing in the recent trends, right? Do you have anything like Ethernet-based object storage in the industry currently? And if it is, then where we are using it? Ethernet-based object storage.
Ethernet-based object storage, maybe I can just check regarding that. But many of the companies are actually moving towards the object storage. So the internal mechanism, maybe we can check, then get back.
Okay, thank you.
Okay, I think we are running out of time now. Thank you, everyone. Thank you.